Most game production usually have these players behind the scenes. Creative director sets the vision and feel of the game, basically defining what the game is all about. Based on his direction, the designers design the gameplay, which provides the basis for the technical and art directors. The technical director is responsible for deciding the technology that would be used for the game, along with major technical decisions. He works closely with the programmers. The art director decides the overall look of the game and provides input for the artist to work on game assets like models and textures. All of this is then given to the programmers for use in game development. So basically, programmers are at the center of game development process. They receive input from the artists and the designers, giving life to their shapes and ideas. Game development requires some modification to the way we think as a programmer. In general, programming involves understanding problems and providing solutions for them, which involves executing a series of instructions. It is important for us to look at problems the right way, because depending on our perspective, the solution will also be different. For games, the problem statement constitutes one or more 3D worlds, populated by various 3D objects having special capabilities provided by the game engine. For example, a ball in a game world can be given physics properties if we want it to bounce or collide with something. The objects can also have behaviors like moving with key press or triggering an event upon interaction with other objects. It's these behaviors that we will write codes for. For the sake of standards, we will refer to the 3D game world as a scene and every object in the scene as game objects. The behaviors and capabilities will be referred to as components, which can be added to game objects. So in a nutshell, developing a game using an engine primarily involves level designing or setting up scenes and game objects where we import, edit, and place the game objects visually within the scene, and programming the behaviors. Now let's look at some of the common capabilities that a game object can have. The ability to change position, rotation, and scale. Having visual objects in the scene is a simple matter of importing game assets from 3D modeling tools like Blender or 3ds Max. Most of the objects in the scene have visual capabilities, unless we specifically want an object to not be visible. For example, a trigger object that triggers certain events in a game. Collision is the capability of whether an object can collide with other objects. Collision can also be used for triggers. Physics capability makes a game object behave like real-world objects. An object can play sound when needed. The object can also have the capability of getting replicated over the network on a remote system. These capabilities are made possible by the services offered by the game engine, and we will program the behaviors to customize them. Now that we understand the requirements for game development, we need to adapt our programming skills accordingly. Game programming is not all about event-driven programming. Unlike regular UI-driven applications, which do some action on the press of a button or any other event, a game is an application that keeps updating itself while events merely change its state. The entire game is basically a loop made to repeatedly update all of the behaviors of the game objects along with its own subsystems to create a living, breathing world. A behavior typically has a start function and an update function. The start function is called only once, while the update function would be called every frame. For example, if there is a behavior that defines a change in position of a game object from X to Y over 3 seconds, the update function of that behavior will move the game object by a small amount each time it is called to make sure that at the end of 3 seconds it is at position Y. What we put inside the update function would ultimately decide the frame rate of the game, so we should make sure its code is optimized. The main loop of the engine is responsible for updating its subsystems that provide services to the game as well as updating the behaviors, which we will refer to as gameplay code from now on. Let us take a look at the general structure of the game loop. The game loop has a specific order in which it updates the subsystems To know why, let us discuss each subsystem shown in this example. Note that this does not represent all of the subsystems in the game engine. The input subsystem polls input devices for detecting any button presses. This subsystem is the first to be updated because input should be constant for all succeeding frames. The physics subsystem, when updated, generally changes the position and orientation of physics-enabled game objects with respect to the time it is being called. Gameplay subsystem updates all the gameplay codes or behaviors. Most engines, including Unity, allows you to customize the order in which the behaviors are updated. Animation and rendering subsystems are closely tied and are responsible for animating and displaying or rendering the game objects. Animation simply involves moving around the game objects using keyframes to make it look like it is doing a meaningful action. Rendering is a rather sophisticated concept that is used quite often for the way 3D graphics are displayed on digital systems. Let's discuss more about that. Essentially, there is no real 3D on a computer. After all, our computer screens are 2D. The way game objects, defined in 3D space, are projected onto a 2D screen is by using vertices, polygons, and textures. Vertices are used to describe points on a 3D object. Each vertex is made up of an XYZ coordinate. They are then used to form surfaces or polygons. Ideally, just 3-point polygons are used in games. Several of these flat surfaces are put together to form the external shape of an object. We can model any type of surface, including curved surfaces. We simply need more polygons. But higher poly count means more work for the system to render it. Polygons only form the external shape of the object, also known as mesh. But we cannot really make out the object without texture. A texture is basically a 2D image that wraps around the mesh, giving each surface's visual information, like which material the surface is made up of, like leather or skin, and color. The textures are wrapped around the meshes using UV coordinates that is used for finding the point of the texture that should be mapped onto the vertex. The part of the texture that maps onto a polygon is then stretched and scaled in a way to cover the polygon completely. We also have a camera setup whose position and orientation is used to determine the perspective, that is, where you want your audience to look. Each polygon is rendered by first calculating the position on the screen it should be projected and the area on the 2D screen it would cover, but only if it is facing the camera and is in the visible range. Then the color information for the rendered area of the polygon is fetched from the texture and is used to light the screen pixels.
Started a long time ago, in a world that was completely made up of Hearthstone, Heroes of War. Wars are only won upon the anvil of honor. Victory or death!
Well played. Before we start building out our game, we're going to have to create the new game project. Here I have Unity opened up, and you'll see in this window if we actually had projects we had worked on in the past, they would be listed out here under the Projects tab. We're going to create a new project, and we're going to call this Super Zombie Runner. Our game is going to be an endless runner, and these are very popular games, and they're also easy to make. In this course, we're going to focus on the essentials of what makes an endless runner, such as our player, spawning objects, and trying to avoid them so that we don't die. Once you've selected a location for where you want to save your project, make sure you select the 2D mode so that Unity knows how to 1. Import artwork and to convert them automatically into sprites instead of textures for us, and 2. It'll also fix the way that the camera view is so that we'll just see the 2D mode view. When you're ready, click Create Project, and Unity will create this new project for us. Before we get into bringing in the artwork and the stuff we'll need for our game, I just wanted to take a moment to talk about configuring the layout of Unity. By default, this is what you see. Now, usually, I like to have the Game tab below the scene. I move the hierarchy next to the inspector, and I'll put the project and console together at the bottom. And also, let me move the inspector closer to hierarchy, so I now have this panel split between the hierarchy, which will be everything inside of our game, the inspector, which displays all the properties of any of the game objects in our scene that we select. The console is where we'll use for debugging to trace out issues and values that we see inside of our game, and project is where all of our files are. Here in the scene view, we'll be working with all the game objects and laying out our game, and in the game, we'll be able to preview what we're doing, and we'll also be able to see how the game is running when we hit the play button. When you're happy with a layout that you feel comfortable with, you can always go to the Layout tab and save that layout. Here, I've already saved out my own layout for Scene Game Stacked. I'll rerun it, and you'll see it's similar to what we just laid out, except this is more in the middle. Before we move on, let's add the artwork that we'll need in our game. Here in the Assets folder, we can create other folders in order to better organize our files. Simply right-click in the Assets folder and select Folder from the Create menu. Here, we'll call this Artwork. Now, I've already created all the artwork we need for the game, and I've actually organized them in folders for us. If we go into the Artwork folder that comes with the files, we can select the 3 folders of artwork and drag them over into our project into the Artwork folder. You'll see here in Unity that we can now drop this down to see the files as well as select them and see the files here. If you'd like to see items in list view, you can drag the slider here, and now all the folders will be listed out. This is convenient when you're going through and you have a lot of artwork that you need to go through or other files such as scripts, and you want to see a lot of them and organize them a little bit better. Next, we'll talk about how to work with the artwork in our game, and we'll explain what a sprite is and how to clean up the graphics so that they're ready to use inside of our scene. Now we're ready to save our scene. If you hit Command S or go to File Save, you'll be able to save the current scene we're working in. Let's make sure that we save this inside of our Assets folder, and let's make a folder called Scenes. Now inside of Scenes, we're going to call this Game Staging, and for the rest of the project, we'll be working inside of this scene. Normally, your game can contain multiple scenes, so I like to keep them organized in their own folder. Let's hit Save, and you'll see that this shows up inside of our Asset folder. If for any reason, when you relaunch the project, the default scene doesn't get loaded, you can simply go into the Scenes folder and double-click on it to reload that scene. It's also important to note that when you're done making any changes to a project, you should always save the scene before quitting. Now, let's move on and take a look at how to work with sprites within our game.